make sure we understand what this means. All right, so let's take a robot. Let's take this one. Oops. 2, 3. And I'm going to have, oops. Yeah, okay. So I'm going to, this is a 4-joint robot. Okay. Here's theta 1. Here's theta 2. Theta 3. Okay, and theta 4 is going to be this. Okay, and I'm going to have a reference frame like that. Okay. All right, so revolute joint, revolute joint, revolute joint, prismatic joint. Okay, up and down. All right, so you see these robots actually a lot in factories. Okay, what do these things do? Well, these 3 joints do the XY motion, okay, in the plane. Okay, 3rd joint changes orientation. Okay, and the 4th joint, okay, is linear motion in the z direction. So, you know, it's a good pick-and-place robot. So, you know, if you're working on a tabletop, see this robot, pick it up, move it, place it. Okay. So you see this in certain chip insertion robots, for example. Okay, often called a SCARA robot. SCARA robot, and I don't remember what it stands for. Okay. Okay, let's analyze this. All right, so let's draw a reference frame. So let's put the reference frame, okay, say here. Let's say it's sitting on a table. Here's my x-axis, here's my fixed frame, x, y, z axis. Okay, link length, say L1, L2. And let's say this is at the same level as the fixed frame. Okay. All right, so let's start with the forward kinematics. Okay, so this I think everybody knows how to do. So T is e to the S1, theta 1. 4 joints, so up to e to the S4, theta 4 times m. Okay, so let's start with m first. M is what? M is the orientation of the tool frame in the home position, or the 0 position. Okay, so the orientation is the same as the fixed frame. What about the position of the end effector frame? Well, let's see, in the y direction, okay, it moves L1 plus L2, otherwise everything is 0. Okay, so there's my M. Okay, let's find S1 now. Okay, what's omega 1? Omega 1 points in the z direction. It's a revolute joint, so it's 0, 0, 1. Okay, what's V1? V1? Anybody? How do I find V1? Okay, it's only been less than 2 weeks since the midterm exam. Okay, so this is worrisome. V1 is 0. Okay, very good. Why? Because Q1, 0, and V1 is minus omega 1 cross Q1, so 0. Okay. S2. S2. Omega 2 is it's a revolute joint. Points in the z-axis. Okay. Okay, so it's either one of two things. Either you forgot, or it's so easy that you're insulted by my asking you this question. Okay, I think maybe it's the latter. Okay, it's 0, 0, 1. Okay. V2. Well, I guess we should write Q2 first. So Q2, a point on joint axis 2. Maybe 0, L1, 0 is a good choice. Okay, so V2 is minus omega 2 cross Q2. Let's see, so omega Q, boom, that. So it's the positive x direction. So this is L1, 0, 0, I believe. Okay, all right, so there's V2. Okay, S3. Okay, let's do this. S3, you're getting the hang of it. Okay, omega 3. All the omegas are the same. Okay, they point in the z-axis. Q3, let's just take 0, L1 plus L2, 0. So V3 is minus omega 3 cross Q3, which is L1 plus L2, 0, 0. Okay. Finally, S4. Okay, S4, prismatic joint. Omega 4 is, okay, 0. Prismatic joint. So omega is 0, but V now is, V is the joint axis, is the unit vector in the direction of the joint axis. Okay. V4 is, what do you think? 0, 0, minus 1. Very good. Okay, done. Okay, that's for kinematics. Okay, now let's find the Jacobian. The space Jacobian Js of theta. Okay, so like I said, we have available, to us two choices. One is to use the formula. Okay. Let's not use the formula. Let's use our intuitive reasoning. Okay, so first column. First column is what? S1. Okay, so S1 was 0, 0, 1. That's the omega. And then V is 0, 0, 0. Okay. Okay, second column. Okay, I mean, we could do this. We could do add e to the S1 theta 1 times S2. Okay, I mean, it's not too hard for this. Okay. Let's not do it that way. Let's leave this for now. So what's the interpretation of it, of the second column? Interpretation. Now let me call this S2 prime. Okay, S2 prime. Okay, interpretation. It's the screw for joint axis 2. Screw for joint axis 2. But now theta, these thetas can be arbitrary. Okay, so, okay. So screw for joint axis 2 with theta arbitrary. So omega 2 prime, what's the axis? What's the direction of joint axis 2? Direction of joint axis 2, always in the z direction. Okay, so this part doesn't change. Okay, now let's find q sub 2, q2 prime, a point on joint axis 2. Okay, could change. Depends on theta 1. Okay, so L1 cosine theta 1, L1 sine theta 1, 0. Okay, there's my q2 prime. Okay, and then v2 prime is minus omega 2 prime cross q2 prime. Okay. All right, so what is it? All right. Swaps, and I always forget which sign. One of these becomes negative. Okay, let's do it. So it's z cross that, boom, it's that. So it's x becomes negative, y is positive. So x positive, y negative. So I believe this becomes L1 sine theta 1 minus L1 cosine theta 1, 0. Is that right? Okay. There's my v2 prime. Okay, v3 prime. Sorry, so let's now find s3 prime. Okay, omega 3 prime. Direction of joint axis 3, always the axis. Okay, q3 prime. Arbitrary point on joint axis 3. Well, L1 C1 plus L2 C1. So let me use the C1 for cosine theta 1. We have L1 S1 plus L2 S12, 0. Okay, so V3 prime is minus omega 3 prime cross Q3 prime. Okay, which is equal to L1 S1 plus L2 S12 minus L1 C1 minus L2 C12, 0. Okay, so there's my third column. Okay, fourth column. Oops, S4 prime. Okay, what's omega 4? Omega 4 prime? Omega 4 prime? It's what you think it is. Not tricky. 0. Okay, because it's still a P joint. Okay, once a P joint, always a P joint. V4 prime. Direction of joint axis 4. The direction. So here I'm moving around. Okay. Joint axis 4. Always pointing in the same direction, right? The same. Okay. All right. So you could have used the formulas, okay? But in this case, you know, it's pretty easy, right? To just by inspection write down the columns of the Jacobian. Okay. So if we put everything together. Okay, J sub S is 0, 0, 1, 0, 0, 0. Okay. Second column is 0, 0, 1. They're all 0, 0, 1. And this is L1 S1 minus L1 C1, 0. Third column, 0, 0, 1. L1 S1 plus L2 S12, minus L1 C1 minus L2 C1 2 is 0. Fourth column, 0, 0, 0, 0, 0, minus 1. Okay. So it wasn't too bad. All right. All right. That was fun, I think. Let's do another. Okay, let's do this one. Let's do that. Okay. All right, so let's put the fixed frame here. Call this my x, y, z directions. So you get the idea, right? Okay, let's find J sub s. Okay, first column. S1 prime. Well, omega 1 prime is z-axis. Okay, v1 prime is just 0. Okay, that part was easy. Okay, second column. S2 prime. Omega 2 prime. Axis, direction of joint axis 2. It's not fixed now. It changes with theta 1. Okay, what is it? Well, this is not too bad, I think. It's just, let me write in vector form. It's L1 cosine theta 1, L1 sine theta 1, 0. Right? Think about direction of joint axis 2. Okay, depends on theta 1. So what's that? V2 prime. Well, first find Q2 prime. Q2 prime is 0. So V2 prime also 0. Okay. Okay, S2. S2 prime. Third column, S3 prime. Okay, what's omega 3 prime? Direction of joint axis 3. Joint axis 3 is a prismatic joint. So this is 0. V3. V3 is what? Okay, V3 is joint axis 3's direction. V3 prime. Okay. Which way is it pointing? Oops. All right, maybe it's you have to do a little bit of calculation, right? So the direction of joint axis 3 depends on theta 1 and theta 2. Okay, but it's not too bad, I think. So I mean, you know, I don't think no one's going to get mad if I write. Okay. S2, oops, 1, 0, 0, minus S2, 0, C2 times 0, 1, 0. Okay, so it's rotation around Z, rotation around, that's rotation around Y. This should be rotation around X, right? Okay, sorry, there's a mistake. 1, 0, 0. C2 minus S2, S2, C2. Is that right? Okay, should be that. So multiply these three things. That's just minus S1, C2, C1, C2, okay, and S2. Okay, 3 prime. Okay, S4 prime. Okay, omega 4 prime is what? Direction of joint axis 4. Same as 3 prime. Same as 3 prime. And let's see, V4 prime. Okay, find the point on joint axis 4, origin. Okay, origin is always on joint axis 4, I think, right? So 0. Okay. Okay. Let's do the fifth column. Direction of joint axis 5. Ooh. Okay, I don't want to think about this. Okay. Okay, so try this at home. Okay. And it gets worse. Okay, get worse. It gets worse. Okay, so, sometimes you have to use the formula. Okay, unless if you're really good at just multiplying rotation matrices in your head and getting the direction. Okay. Okay, I think this is a good place to stop. We'll stop here. Thank you.